Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Buttonwillow School, home of the Roadrunners, and we're here to... Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Samantha. And Samantha, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else is 1-866-636-6284. The email is dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Do you have all of that social media stuff?
No, I only do YouTube.
You only do YouTube?
Yeah.
Well, guess what? In 2 hours from now, you're going to be YouTube famous because you'll be on YouTube. Did you know that?
Yeah, I watched my brother on
Yeah, because your
YouTube.
brother was on last week and you were able to watch his program, right? So anyway, Samantha, where do you go to school and what grade are you in?
I go to Stockdale Elementary and I'm in 4th grade.
How's 4th grade?
It's pretty good so far.
Pretty good so far?
Yeah. I
What-
like the gate in it.
You like what?
I like doing gate and that we can do track.
Okay, so you like being part of the GATE program.
Yeah.
And you like track.
Yeah.
So what do you like about track? Is there a certain event or thing that you like to do?
I just like running.
You like running?
Yeah.
All right, so are you more of a sprinter or a distance runner?
I'd probably say more of a sprinter.
More of a sprinter. So
Yeah.
you can do that 100 yards pretty quick.
Yeah.
Do you like running around the whole field 18 times?
Probably not.
Yeah, all right. So you're more of a sprinter then, right?
Yeah.
You do it really quick. And so what else is, if you could change something about 4th grade, because you said it's pretty good so far, but it's not excellent, is it?
No, not really.
What, if there's something you could add to it or change or take away or something, what would you do to modify 4th grade?
I would add that the sports teams, you could do that in 4th grade too.
Oh, okay. So the after-school sports.
Yeah.
Okay, so like the football, volleyball, basketball, things like that.
Yeah.
All right, so that's a good idea, right? If you want to play and you can play, then why not start it in 4th grade? You say, right?
Yeah.
All right, very nice. Now, what kinds of things are you doing in math in your regular classroom?
We did like a lot of area models and multiplication last week.
Okay.
And then like 2 weeks ago we did like a lot of division.
All right, so you're pretty comfortable doing multiplying and dividing.
Yeah.
And doing area models with the multiplication.
Uh-huh.
But what math did you do today?
We didn't do any math
Yeah,
today.
see, that's why you didn't do any math, right? So we're going to do some math. We're not even going to wait. We're going to start doing math right now, all right? So we're going to play a game called Always, Sometimes, Never. Are you ready for this?
Yeah.
Okay. So what I am going to give you is a problem, and you're going to have to decide if that is always true, never true, or sometimes true, all right? So go over to the board if you would, please. And I want you to write x plus 7. Oh yeah, don't let your hand touch the board, that way it'll. So x plus 7 equals 19. Now the way that is written, is that always true, never true, or sometimes true?
It depends on the number
So what's your answer? Always, never, or sometimes?
sometimes.
All right, so why is it sometimes? Explain to me why it would be sometimes.
Because, say, 7 plus 8, that equals 15, not 19. But 7 plus 12 is 19.
Okay, so why don't you underneath that put x would be equal to 12. And then that would satisfy that to make it true, correct?
Yeah.
So as far as the initial question goes, always, never, sometimes, your first response was?
Sometimes.
Sometimes. All right, let's spin the wheel and see if Samantha is correct. Hey,
Right
there you
on.
go. It is sometimes
Yeah.
correct. Nicely done. All right, so you can go ahead and put the pen up there. You can leave that. So that was a pretty easy problem, right?
Yeah.
Because you saw X, and do you know what X is called in mathematical terms when you have a letter representing something?
No.
That's called a variable, all right? Because it can vary, and we'll get into more of that later on. But anyway, a reminder that this is our 20th season on Do the Math. We've been celebrating all season long. And as a reminder, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right, so Samantha, if you wanted to measure something, name one thing that you could measure with anything.
My soccer cleat.
Your soccer cleats.
Yeah.
How would you measure those?
Probably with a ruler.
Probably with a ruler, maybe even something more precise, right? Because they're not very long, are they?
No.
Okay, so you could use a rule to measure those,
Yeah.
right? Let's say we wanted to measure your weight. How would we do that?
With a scale.
With a scale. Can you think of other things that you could measure and use different things besides a rule and a scale?
You can measure time with a clock.
Ah, there you go. You can measure time with a clock. That's a very good one. Can you think of anything else?
Not at this moment.
Did you know that you could use your body to measure things? Have you ever heard of stuff like that?
Yeah, like I heard this part of your thumb is an inch.
That part of your thumb is an inch.
Yeah.
Put your thumb up there.
Let's see. Let's see about
Part
that.
of your thumb. So,
So she's
is
saying
it
the
your
first
thumb?
knuckle
Is it
here.
a kid's thumb? Is it an adult's thumb? Is it a human's thumb?
I'd probably say kids,
So a kid's thumb.
because we said that.
I know we're not going to bring this over to the camera right now, but that's almost an inch. Now, how old are you?
10.
10. Do you think if you were 16 it would be the same size?
Probably not.
Probably not, right? It's probably going to grow, right?
Yeah.
Okay. So let's take a look at what we've got right here. The human body was an easily accessible measuring tool, but over time, some standard measurements were added to the definitions. All right? So foot. That came because somebody said, hey, you know what? The length of my foot is this, and that's what a foot is now going to be. All right? So the length of the average man's foot is 12 inches. All right? Originally, it was 11.42 inches. All right? Now, do you think that's pretty accurate? The
Yeah.
length of a man's foot is 12 inches.
My dad's like an 11, so.
Oh, his size, right,
Yeah.
for his shoes is an 11?
Like, well, it depends on the brand too. So.
It depends on the brand, okay. So if we're talking about shoes, we need to consider the brand. And then we have to take a look at the average man's foot. So do you think your father's foot would be a little bigger or a little smaller than the average man's foot?
A little bit smaller.
A little bit smaller. All right, we're going to do this.
We're taking shoes off, everyone.
Here we go. We're going to take my shoe off. Okay? I want you to measure that. Okay?
Okay.
So we're going to go from, so we'll put it there at that camera. So where do you think, so let's put a piece of paper here so we can get these like that. Do you think that's pretty safe to say that that's the front?
Yeah.
Okay. So take a look. I can't see it. Where do you think the back of this shoe is?
Probably about 13.
About 13,
Yeah.
right? So
Well, that's
that looks at
counting the
about
bumper though.
almost 13, right? Do you think it's closer to 12 or 13?
13.
13, all right. So do you think that's like an average size?
I'd probably say it's a little bit bigger than the
Okay.
average size.
But it's pretty good, right?
Yeah.
I mean, it's pretty close to 12 inches, isn't it? All right, let's take a look at the next one we've got here. It says an inch was the width of a man's thumb. Okay, so this is going to be a little different than your thumb, right? And what we looked at, so let's have, can you hold that end of the yardstick right there? So we'll take my thumb and we'll take the width going this way, all right? And we'll put it right there. And would you say that that's pretty close to like I'm lined up at the end?
Yeah.
And we'll see if the other camera can get that. I'll leave it right there. And
There we go.
what do you think that measures out at?
An inch.
It looks like 1 inch, right?
Yeah.
So they were pretty good on that. All right. Ah, they even got a bell on that one. All right.
Hey.
So the span was the length of a spread hand. So if I spread my hand like that, what should it be?
Roughly 9 inches.
Roughly 9 inches. All right. So you go ahead and hold that there, and I'll put my pinky there, and I'll put my thumb there. So what is that about?
9 inches.
It's about 9 inches. All right. So I think they got that on the camera there. We'll go ahead and put it there one more time, and it's about 9 inches. Okay. A yard was the width of a man's waistline. Okay, we're not going to do that. It says in the 12th century, King Henry I determined that a yard was the distance from his nose to his thumb when his arm was outstretched. So you're going to hold on to this for me down at that end. All right, we're going to put it up so it's at my nose. Okay, and I'm going to put my arm all the way out and at my thumb. Do you think that's 36 inches?
Yeah, that's
We're
gonna
a little
fall
shy,
short
aren't we?
here by about
Yeah.
6 inches.
Yeah, all right, so,
Pretty short.
King
Maybe I got
Henry was
short
a
arms.
big dude.
right,
Yeah.
okay. A hand breadth, have you ever heard of that? A hand breadth. Now you've heard of a foot, right?
Yeah.
You've heard of an inch.
Yep.
Have you ever heard of a span?
Yeah, like a wingspan on a bird.
Okay, good, a different kind of span, right? Have you heard of a yard?
Yes.
Yeah, you knew, because you knew looking at this was a yardstick. You knew it was 3 feet, you knew it was 36 inches.
Yeah.
Have you ever heard of the measurement, a hand breadth?
No.
Okay. So the length of the average hand, generally accepted to be 4 inches. Now, what we're going to do is we're going to hold it this way, okay? Now, some people think that your hand, so go ahead and hold the yardstick steady for me right there, all right? Would be from here, where your wrist is right here, all the way up. But that's not your hand. These are your fingers. This is your hand.
Yeah.
Okay, so let's go ahead and I'll go there. And so right here, do you think that's the end of my hand?
Yeah.
Would you say that is? All right, so I'll put my finger right there. And what is that about? So let's hold it up so the camera
It's
can see.
about 4 1/4 inches.
It's about 4 1/4 inches, right? So I like how you're getting very precise with that, right? And you can see that that would be a quarter, that would be a half, right? So I like how you're able to actually take a look at the fractional part of a rule right there and see that those different parts of an inch right there. So what do you think? Pretty dependable what they had there?
Yeah.
It kind of works, right?
Yeah.
It's a little bit off, a little bit, but that they had to start somewhere.
Yeah.
You like that? So you can use your body for measurements. At least that's how they started it. And that is today's Math in the News. Yep, Johnny reminded me horse height measured in hands, right? So there's a lot of things, furlongs, furloughs.
Smoots. In Boston, when they measured that bridge by the one freshman at MIT, and they just had him lay across the street all the way to the end of the bridge across the Charles River, 153.2 smoots
There you go.
was the length of that bridge.
There's all sorts of different measurements, and we will have other types of measurements on different days for today's Math in the News. It was the human body. 636-4357 is the phone number. We do have phone tutors available Tuesdays and Wednesdays. Samantha, a 4th grade student from Stockdale Elementary, is in studio with us today. And Samantha, I need to know, what is the most difficult thing in mathematics you've had to deal with so far?
Probably the area model.
The area model. Well, how about if you go to the board and let's work with the area model, and maybe we can get you a little more comfortable with it. You're probably good with it right now, but if it's been the most difficult thing, let's go over it one more time just to make sure you're good with it, all right? All right, So why don't you explain to Devin what you know about the area model now, and then you guys can work on a problem together.
So there's an area model. It's most likely like a rectangle or a square. And it has different parts depending on the place values. So if there's, say it's 47 times 23, there'd be a 40 and then a 7 area.
So if you could draw this out, you would break it up by place value for each of the two factors. Now in this case, they would both have 2 digits. So
Yeah.
in each dimension, you would have 2 separate place values represented as far as portions of this rectangle or square.
Yeah.
So for 47, you would represent this as 40 plus 7. So
Yeah.
the top portion would represent 40, or 4 tens is our place value, and then 7 ones.
Yeah. And then you're multiplying it by 20. So, and then 3. 20
And-
plus 3.
And so what this represents is 40 plus 7 times
Yeah. Times.
20 plus 3,
Uh-huh.
okay?
So 40 times 20 is 800.
Now, generally speaking, is there a specific one of these portions that you're finding the area of first? Because what we're really doing is we're finding the smaller areas of each of these little rectangles, and then presumably we're going to add them all together to find the total area of the whole rectangle, correct?
Yeah.
So do you generally like to do this one first, or does
Yeah.
it depend?
Yeah, I generally do that one first because it's the 10s times the 10.
You like to do the larger place values first?
Yeah.
Okay. Go ahead and continue.
And then 40 times 3 is 120. And then 3 times 7 is 21. And 20 times 7 is 140.
Okay, so then once we have these 4 values together, I think we kind of mentioned this earlier, at this point we're going to add all of them together to find the total area of this rectangle.
Yeah. So 21, 140, 120, and 800.
So Samantha, you actually started with the smallest of the portions on top when you added them, when you started arranging them, which is almost the opposite of when you started finding the products of these smaller areas. So I think it's an
Yeah.
interesting dynamic as far as going back and forth when it's more comfortable to work with smaller values versus finding larger values.
Yeah,
Okay?
it's kind of weird.
Oh, it's not weird, it's math.
So you add all these together. 1 plus 0 plus 0 plus 0, 1. 2 plus 4 is 6, plus 2 is 8, plus 0, 8. And then 1 plus 1 plus 8 is 10. So the answer is 1081.
So what this really means is that 47 times 23 should equal 1081.
Yes.
Now, if you've started working with standard multiplication, it's interesting how these two kind of tie together, because you're taught to work the ones place value of the bottom factor here with each of these two. So we would do 3 times 7, right? Which would equal what?
21.
Okay. Now, we're going to multiply by the 4 here, and sometimes we're taught we have to carry numbers over. In this case, we're not going to do that, right? I just want you to tell me, first of all, what does this 4 represent? It's not really worth 4, is it? What is this 4 worth, or what is its value?
40.
It's 40, right? So what would 3 times 40 equal?
120.
Okay. Now, we're going to move over to this 2. Now, this 2 doesn't represent just 2.
20.
It's 20. So we're going to do 20 times 7, which is?
140.
And then we're going to do 20, and what did we say this 4 represents?
40.
So 20 times 40.
It's 800.
Now, what's interesting here is we did all the same multiplication here
In a
with
different
this,
order.
but it ended up being in a different order, but it still gave us the same pieces, the same elements. So here's the connection that sometimes people forget, and it ended up being very similar to the order that you lined them up in to order them. And since we know that there's a property of addition, that if we move these values around and add them, they're still going to end up with the same sum.
Yeah.
We don't have to go through everything all over again. We know that this is 1,081 without having to add all over. So we can see the connection between the area model and standard multiplication.
Devin, do me a favor. At the bottom of the screen, write 1,080
Okay?
and write 1,082 somewhere.
Let's go just right over here next to it.
And Samantha, write 1,083 somewhere down there. Over to your left, farther.
Yeah, we can move it over to that side.
Now, there are going to be times in your life where you have to take tests and you need to do them quickly. Let's say they gave you the problem 47 times 23, and you don't have time to work that out. Those are your four options: 1,083, 1,081, 1,080, and 1,082. They're all very close together, right?
Yeah.
How do you know which one's going to be correct without working it out? Do you have an idea yet how to do that?
No.
All right. So Devin, point out the ones place in those two numbers, the 7 and the 3. And Samantha, multiply those two numbers and what do you get?
7 times 3 is 21.
Okay, so the answer has to end in a 1. That's a quick way to do these things. All right? So you can see that the answer, you're like, oh, those are all very close together. There's not much difference in them. The only difference is the place value in the ones place. You know that 47 times 23 ends with a 7 and a 3, so you know the answer must end in a 1. Does that make sense?
Yes.
All right, good. Erase the board. It is time to move on to the next one. So now, did you choose 47 and 23?
Yeah.
Excellent. Put them back up there. Write 47 times 23. Now, what I'd like you to do is between the 4 and the 7, put a decimal point. And right before the 2, put a decimal point. So now you have 4.7 times 2.3. So work with Devin on how to solve that problem and how to represent it correctly. And if you're stuck, that's why he's there.
What goes through your head right now as far as what stands out and what are you thinking is going to happen before we actually start working this through?
So there's obviously nothing here, so that would be a 0 right there.
Right.
And then this is a 10, and this is a 10, and this is a 100.
Now let me ask you this. How comfortable are you with decimals? Have you interacted with them a lot?
Not a lot, but I'm
Okay. What do you know about decimals?
that, well, I know their place values, and I know that this is the ones, and this does not have a 1.
Okay. So what we can start to consider here is that we can break some of this up here, right? If we think about each of these place values, first of all, this first place value represents, like if we have hundreds and then tens and then ones, what do we call this place value? Tenths, right? So if we think about this as a tenth, right? If we say that 0.1 equals 1/10, then that means that we can think about 4.7 in a specific way, right? We can think about 4.7 as 47 tenths. So I want to write that down right here, 47 tenths, because I think if we don't have a specific strategy for how place value works when we're multiplying, it's important to recognize the value of what it is that we have, right? Now, what is the next place value over? So
Thousands.
well, would we go straight from tenths to thousandths?
No, hundredths.
Hundredths, right? Now, if this is equal to 47 tenths, how many hundredths would this be equivalent to?
470.
470. Great reasoning there, right? Because we're thinking about, okay, well, there would be essentially a 0 right here.
Because there's nothing there.
Great. So we're thinking about this as 470 hundredths. Now, maybe it's easier if we multiply these together here, right? So in this case, how many hundredths do we have?
3. No,
Right.
23.
We have 3 hundredths in this place value, but overall in this we have 23 hundredths. All right? Now that's important to keep in mind when we start multiplying for a reason that we'll explore later on. But Another thing to keep in mind too, and this is a little bit of a play in regards to how we work with fractions, is how comfortable are you in regards to the relationship between decimals such as this and its fraction version?
Haven't really gotten into that
Okay.
yet.
Well, the nice thing about decimals is if I say this is 7/10, how would I write that as a fraction?
7/10.
Yeah, that's the beauty of it, is that it's telling us what the fraction would be, right?
Yeah.
7/10. Now, how would I write this as a fraction then?
23/100.
Absolutely, 23/100. Now, this value is 4 7/10, so I'm going to go ahead and represent this as a fraction here, 47/10. There's one other element here that's really helpful. It's in regards to how we multiply fractions together, because that's essentially what we're doing here. We're trying to multiply these and get a product. So what do you understand about how we would multiply fractions?
Well, so
So for example, if I was going to multiply 1/2 times, let's say 2/3.
you'd probably do 1 times 2.
Okay?
So 2. And then 1/2 is so half of 1. But I don't think you would multiply the 2 and 3.
So I'm going to shift a little bit here, because as a 4th grader, there are a lot of these concepts that you won't really dive into in depth. But let's use what we know to show how this might work, okay? We did the area model a little bit earlier. And you can actually multiply fractions using an area model. But it's going to work a little bit differently here. So I'm going to go ahead and make a rectangle here. And I'm going to have one dimension represent 1/2. Now in this case, I'm going to split it in half. And only one of these halves is going to be shaded in. And I'm going to put it in this direction, right? Over here, we're going to do 2/3 to represent the other fraction, okay? And in that case, I'm going to split it into thirds going this way, and I'm going to have my thirds filled in, my 2/3 filled in with this line going through. Now, let me ask you a question. How many portions do we have altogether here?
6.
6. Out of those 6, how many are overlapped by the 2 different shades?
2.
2. So 1/2 times 2/3 equals 2/6. Now, what do you notice about the multiplication of these two fractions?
That 2/6 is less than 1/2.
And that's an interesting approach. When we multiply a fraction by a fraction, sometimes we get something greater. That's one of those always, sometimes, never cases. But what do you notice about the values when we're multiplying and how it relates to our product?
That 1 times 2 is 2 and 2 times 3 is 6.
That's good knowledge. Now let's take that knowledge and come back here. 47/10 times 23/100. Now, the good news is we don't have to do all of this multiplication from the beginning again, because
Because it's 1081.
it's 1081. That's great. Over what?
1000.
1000, right? Because we know that when we multiply fractions, we can multiply terms across. So this is 1000. Now, 1081 thousandths. How could we write that now? Let's go back to this decimal. How could we write that as a decimal?
Maybe 10.81.
If we write 10.81,
No.
oh, go ahead.
1.81.
We want to keep that 0 there, right?
Oh yeah,
1.081.
1.081.
Now, here's something that's going to make this whole process so much easier, right? Because it seems like a lot of work for multiplying with decimals. But we do all of that so that we can highlight this piece here. How many, if this was 47 times 23, which it originally was, how many decimal places did we move over in total? So for example, 4.7, how many places did we move this decimal over from 47?
1.
Just 1, right?
Yeah, just 1.
Okay. Now, what about down here? This was 23. How many decimal places was this moved over by?
2.
2. Now, we remember that 47 times 23 was 1,081. How many decimal places was this moved over by?
3.
3. So when you're multiplying decimals, because of the way that they relate to the fraction version, when we see that they've been shifted over a certain amount of places, so when we count how many places it's been moved over here and how many places it's been moved over here and combine them together, it's going to be the amount of places we'll move it over in our product. So you're absolutely right. 4.7 times 0.23, or 4 7/10 times 23 hundredths, is 1 81 thousandths.
There you go, nicely done. So Samantha, let me ask you, does your brain hurt a little bit right now?
No, it doesn't
No,
hurt.
it doesn't hurt.
But
No.
did you learn a little something? Did you have to think a little bit more than usual?
Oh, yeah.
That's what I'm trying to get at right there. So the way Devin explained that to you was very good, very in-depth, and brought you back and then back around again so that you can see how to work with decimals and exactly what they mean and how you can work with them. So does that make sense to you a little bit?
Yeah.
Good. Well, when you had to think about it, that's what I wanted you to do. That's why I wanted you to work on some of those decimals right there. Because every time you struggle a little bit and you have to think a little more than normal, that's when your brain grows and you become smarter.
And we just got to make sure the skull grows at the same time so that there's room too. Otherwise, it can
will
get
be.
very
Otherwise, we're gonna
uncomfortable.
be all over the
and you have to
place.
go to the farm. Yeah, it can be
And,
very
yeah, your
painful.
hair starts falling out then too.
That's related to something else.
Yeah, well,
and
that's
a choice
both of us
as well.
right here. All right. Anyway,
Shine.
Samantha, you've done some great work so far today, and for your efforts, you've got yourself a meal courtesy of our friends at the Broken Hill Cafe. So congratulations on that.
Thank you.
And there are a lot of words that mean more than one thing. We'll learn more about that in today's Language of Mathematics.
Hi, I'm April, and today in the language of math, we're going to talk about complementary. So there's this confusion sometimes between complementary and complementary. So complementary at the top here, that means like free, like these hugs here. It's something that you're getting for free, but complementary is what we'll talk about in math, and that refers to angles. So complementary in math is two angles whose measures add to 90 degrees. So a couple things need to happen for complementary. There has to be a right angle or a 90-degree angle. And when I add the two angle measurements together, their sum is going to be 90. So in this case, I've got 60 plus 30, 60 degrees plus 30 degrees, which will give me 90 degrees. And I can obviously see the right angle here. But this set of angles are complementary as well, because this set of angles has a measurement of 63 and a measurement of 27 degrees, and 63 degrees plus 27 degrees is also 90. So you know that you have a complementary pair of angles if their measurements add to 90 and or if they make a right angle. And that is Language of Math today, talking about complementary angles.
There we go. More on the language of mathematics. Did you ever hear about complementary angles before that?
Nope.
Well,
go.
look at that. You learned something else too, didn't you?
That's right.
Yep.
All right. So when you get into geometry, you'll be learning about complementary angles. There's a lot of things going on where we can all gain a little bit more knowledge, and one of them is a series of workshops being presented by the Kern County Mathematics Council. And we've got some information right here because there are a lot of educators that are invited to these things, but there are also parents that are able to attend these sessions as well. So they're absolutely free. They're brought to you by the Kern County Mathematics Council. And we can see right here, we're just going to leave this up for a little bit. I know it's a lot to write down, but even if you went to the Kern County Mathematics Council online, you would be able to find this link and then register for one of the workshops. And they're always on Saturdays from 8:30 to 10, and they've already had a couple. And we can see the one coming up has to do with PEMDAS. So Samantha, have you ever heard of PEMDAS?
No.
Okay, well, in 5th grade, you're going to hear about PEMDAS. all right? It's the order of operations. Have you ever heard of that at all yet?
Yes.
Okay, so you have heard of the order of operations. So they're going to dive into that a little bit deeper on the next workshop coming up this Saturday. Once again, this is brought to you by the Kern County Mathematics Council. And if you go to their website, I'm sure you'll be able to get to that link. But that link is there, and that way you go, oh yeah, that looks just like the one that I saw and do the math. So there it is, and we'll bring that up to you again probably tomorrow. So that way some parents that would like to learn a little bit more on how to help their student, this is another avenue, another resource for you to go to. 636-4357 is the phone number. We do have phone tutors available until 5:30. Samantha is a 4th grade student from Stockdale Elementary who likes track, who prefers to sprint as opposed to long distance running. And so this, you being in 4th grade, you will actually, don't you do like a track meet in 4th grade where your class is part of a track meet during spring?
Yes.
Okay, so you looking forward to that?
Yeah.
Now, like we said, your brother was on the show last week.
Yes.
And you guys are in the same class, so you're always in the same class. Do you think you could, if you raced your brother, do you think it'd be very close, or would you just fly right by him?
I think it'd be pretty close, but I still think I'd beat him.
Yeah, there you go.
Okay,
So it'd
okay.
be pretty close, but you'd beat him, right?
What grade is he in?
They're
my
4th
twin.
grade, so they're
Same,
twins.
same, okay,
Yeah.
all right.
All right.
You
So
know
you
what?
ready for another math
It's
problem?
on TV, so it has to, you know, he has to rise up to the challenge now, because you also have to defend you just said you could beat your brother in a race on TV, so, I mean, you gotta back that up now.
Well, we'll
Is that
see
gonna be a
when
problem?
springtime comes around. They start their
right.
training. All right.
Nothing but luck for you.
Samantha, you ready?
Yeah.
All right, head on over to the board. We're
Here we
going to have you work on another decimal problem. So you are in 4th grade, correct?
Yeah.
All right, so why don't you put 0.04, and let's go plus. So now we're going to do something a little different. Instead of multiplying decimals, we're going to add decimals. All right? Let's see, how old are you and your younger sister together?
18.
18. So you're 10 and she's 8.
Yeah.
All right, so put an 18 under the 0.04. And let's see, how many people are in your family altogether?
5.
5. All right, so
Oh
put,
wait, do you want the dogs too?
why not?
7.
7. All right. And, all right, so let's go 7, and it's the 4 o'clock hour, so let's put 7.4. So now, you kind of work with Devin. How are you going to add up all of those numbers? Because some have decimals, some don't. Some have decimals in different spots than other ones. All right? So take it away.
So, yeah, so first I would probably do 18 plus 7, which is 25.
So right off the bat, I want to just kind of illustrate what exactly it is you're doing. You're going to be breaking up these values by place values that are friendly. So essentially what you're doing is you're treating 7.4 as 7 plus 0.4. And then you have 18 here, and then you have 0.04 up here. And you're starting off by adding these two values together, the 18 and the 7, correct?
Mm-hmm.
Okay, go ahead.
So 18 plus 7 is 25.
Okay,
So I'm just going to write that here. And so 0.4 plus 0.04
okay.
is, well, I'd probably say there would be a existent 0 there. So it would be like 40 plus 4. So I would do 0.44.
So you treated that 0.4, that 4/10ths, as 40 hundredths,
Yes.
and then added that to 4 hundredths. And because they then share the same unit and place value, it's easier to represent them as decimals, 0.44 or 44 hundredths.
Yeah.
Great, okay.
So, and then 25 plus,
So now you're going to add the 25 and the 44 hundredths.
yeah, which is 0.4 4, 4, and 25. So
And-
the answer is 25.44.
So if we think about all three of these values in the same way that you worked with 0.4 and converted that to 0.40, so that they all aligned like they would if it was standard addition, we would end up with 0.4 at the top here. And then for 18, how would we represent that here with 2 decimal places?
Well, 18.00.
Absolutely. And then what would we do with the 7.4?
7.40.
So if then we have all three of these and we just add them using a standard addition algorithm, we would have 4 and 4. Our decimal point holds place because this is, the separation of place values greater than 1s and less than 1s. Now we have 8 plus 7, which is 15. We'll bring a 1 down here, and 1 plus 1, 25.44, right as you had anticipated. And I appreciate the way that you broke things up to be able to piece them back together and make them easier to work with.
Yeah, nicely done. I was going to say, it's amazing how many students come in here and show us how many different ways they approach problems and just take them apart to make them easier for themselves to understand. And the way you did it by taking those whole numbers first and then adding the partial sums to that, just outstanding. So nicely done on that, Samantha. 636-4357 is the phone number. And we do have an opportunity, as we saw at the beginning of the show, to go out and visit some of the students at Buttonwillow School. Today we're at Buttonwillow School, home of the Roadrunners. We've got some students, and today we're going to do another math activity. This involves math from 4th grade, 5th grade, 6th grade, and 7th grade. Even though you guys aren't in 7th grade yet, we're going to do a little bit with it right now. You guys ready?
Yes.
So, who has the first stick to start the game?
Me.
All right, go ahead and read it.
Let's start the game. What is 3 times 2 plus 4?
So what is 3 times 2?
That is
6 plus 4?
7.
6 plus 4 is
10.
10. So who has 10? The answer is 10.
The answer is 10, but what is 12 plus 12 plus 12?
12 plus 12 plus 12. So write it down if you need to. What is 12 plus 12 plus 12?
36.
Who has the answer is 36? You do?
The answer is 36, but what is 5 squared?
Now 5 squared. Does anybody know what squared means if you square a number?
5 times 5.
Right, 5 times 5, right? Because 5 squared is written like this, right? And when you do that, that's the same as 5 times 5. Does anybody know what 5 times 5 is?
10.
25.
25, right?
Oh, I was saying plus.
Yeah, you were going 5 times 2, right? So the answer is 25. Does anybody have that stick?
The answer is 25. The answer is 25, but what is 1/2 plus 1/4?
1/2 and 1/4. That's 1/2 is the same as 2/4. So 2/4 and 1/4 is
3/4?
3/4. And I have that answer. The answer is 3/4. But what is 60 divided by 3? So write it on your paper if you need to. 60 divided by 3. 20. Does anybody have the one that says the answer is 20?
Me. The answer is 20, but what is 28 minus 9 plus 3?
28 minus 9 plus 3.
22.
22. Does anybody have one that says the answer is 22?
The answer is 22, but what is 2 times 3 times 4?
So it's 2 times 3
Times 4.
times 4. So 2 times 3 is,
6.
and what's 6 times 4?
24.
Yeah.
24, you agree?
Yeah.
So who has the one that says the answer is 24?
Me.
You've got it?
The answer is 24, but what is 2 cubed?
2 cubed. All right, another exponent. 2 cubed means to the third power, which means now if 5 squared meant 5 times 5, 2 is what? 2 times 2 times 2, 3 times. So what's 2 times 2?
That's 4.
4. 4 times 2?
8.
8. Who has the answer as 8?
Me. Answer is 8. But what is 8 plus 18?
8 plus 18.
That is 34.
Almost.
36.
8 plus 18. I've got it. The answer is 26. I've got that one. 26, but 2.5 plus 3.5. Now just think about 2 plus 3 is what?
6.
The whole thing is 6, right? Because 2 plus 3 is 5. And what's 1/2 and 1/2?
1 whole.
1 whole. So 5 plus 1 is?
6.
Who has the answer as 6?
I do. The answer is 6, but what is 10 plus 20 plus 30?
10 plus 20 plus 30.
33.
60. Who has the answer as 60?
The answer is 60, and that's the end.
And that's the end of the game. There you go. All right, so you guys did pretty well on that. You guys did math that was in 4th grade, 5th grade, 6th grade, and 7th grade because we did the exponents, and you were aware of that, weren't you? Right, with the second power and the third power, right? So just another little game right there where we all had to listen to each other and help each other out, right? You guys like that one?
Yeah.
There you go. You guys did awesome on that. The students at Buttonwillow School. And big thanks to Mr. Packard, the staff, and the students at Buttonwillow School. We always have a great time every time we're invited out there, and we love going back. And we love going to all of the different schools that we're able to visit throughout Kern County. As a matter of fact, if your school would like a visit from Do the Math, all you got to do is give us a call, let us know where you attend school, and we'll see if we can get you guys on the schedule, and we'll do a little math in your class. In studio right now, we have Samantha, a 4th grade student from Stockdale Elementary. And have you been in Stockdale for a long time, or?
Since TK.
Since TK. So you've been there for a long time.
Oh, yeah.
You know no other school besides Stockdale.
Well, unless you count my preschool.
You remember preschool?
A little bit.
A little bit. But you've got more of Stockdale than you right now, right? 'Cause
Yeah.
You've been there for a long time, right? You've been there 5 years now, right? 6 probably with TK, right?
Yeah,
So you've
with
got
TK.
TK, K, 1, 2, 3, 4.
Yeah.
Right? This is your 6th year being at school there. What is, this is still early for you, but you've still got 2 more years, assuming you stay at Stockdale.
Yeah.
What is something that you're looking forward to when you finally go to another school like junior high school? Or have you even, I mean, you thought about it at all?
Probably if they have a soccer team.
If they have a soccer team.
Yeah.
All right.
Because we don't have a soccer team in our school.
No. And you know what, I'm not really sure if they have soccer teams in junior high or not, but I know in high school.
Yeah,
You'll
high
definitely-
school they do.
Yeah, you'll definitely. So is that your favorite sport to play?
Yeah, I play club soccer, so.
You play club soccer. You pretty good?
Yeah, I'm
Well,
on the
that's
18.
probably why you like to sprint, because you're going to have to move a lot.
Oh, yeah.
And at short distances, right? It's not like you're running a mile.
Yeah, but
mean-
I'm a midfielder, so.
Probably over the entire night you're running a long way,
Oh, yeah.
but a lot of short bursts and things like that.
Is
All
there
right.
a club soccer team you'd like to challenge right now, just like you challenged your brother to a race earlier in the show? To just kind of put it out there and lay it down?
Well, you want to have you as the goalie and see how many goals she can make or something?
She doesn't want that. This is going to be brick wall. Here we go.
Yeah, all right. Yeah, they buzz you on that one. Yeah, you like that, huh? All right, Samantha, head on over to the board for me. What I'd like you to do is, because you're in 4th grade, we're going to play 4-4s.
Okay.
All right, Devin's familiar with this game. What I'd like you to do, Samantha, is write 4 4s up there, but space them out a little bit so they're not right next to each other. All right, so go ahead. So put a 4 and move a little bit over and put another 4 and do the same thing. Make 4 4s. And after the last 4, put an equal sign. And I would like you to select a number between 0 and 10.
7.
7? All right, so put a 7
All
at
right.
the end of the equal sign. All right, so Samantha, here are the rules of the game. You must use all 4 4s and make them equal to 7. Now you can use any mathematical symbols and operations you want in between the 4 4s. So you can add, subtract, multiply, divide, use whatever mathematical symbols you can think of. I'm not going to give you more because you might be like, I don't even know what you're talking about, okay? So only the ones that you're comfortable with and familiar with. Now you can do an operation more than once, okay? So you don't have to just add once and subtract once or whatever, okay? But there has to be a symbol in between each of the 4s to make all of those 4s, the 4 4s, equal to 7. All right, so go ahead and start at it. And if you need to, you know how the eraser works, so you can use that.
So I'm gonna do a multiply. Wait, no.
And this will also help you with order of operations.
That's right.
I'm gonna do a division,
Okay.
which is 1. Maybe to addition.
And I appreciate the way that you said maybe here, because this activity is great for trying things out and getting closer each time you try something. So it doesn't hurt to try something and see where it takes you.
Okay. So 1 plus 4 is 5.
And then getting from that 5 with 1 4 remaining to get to 7 is going to be a little bit tricky, right?
Yeah.
Okay.
So I might do multiplication here. And then do
So that looks like we're going from multiplication to subtraction is what you're trying to do for that second one. Is that
Yeah.
correct? So we'd have 4 times 4, which is 16.
minus 4 is
Minus 4 is
12.
12. Now we've got 1 4 left, and we've got to get to 7.
Yeah.
So subtracting isn't going to get us there. That's going to get us to 8. So
Yeah.
let me reflect on something that Mike threw out there a little bit in regards to other types of symbols that you use in math, right? And when we think of symbols, we can think of add, subtract, multiply, the operations, right? Are there any other type of symbols that you use in math that might be helpful?
We have division, multiplication, addition symbol, and
Now,
subtraction.
going back to that earlier conversation about what Mike had mentioned with PEMDAS, you mentioned 4 of those terms right off the bat. You mentioned multiplication and division, addition and subtraction. Now, there's also these other elements that we consider when we think about the order in which we do situations like 4, 4, or when we have multiple values in an expression. So we have these 4s down. Is there any indication or thoughts in your head on what these might represent?
That one could be the PEM. What is it?
So what does this letter stand for in this mnemonic here?
Well, the math symbol.
It doesn't necessarily have to be a math symbol, and I think that's sometimes something that we forget to consider. In fact, when we think about what this stands for, we actually think about it more in writing or reading. Because this represents, I'll move this over here, this represents parentheses. And we can think about this as any grouping symbol that we generally consider. So the value of having that as part of this sequence is that we can decide which we can do first without having to worry about doing it from left to right. So anything that is grouped together, because of the way this is structured, we do that first. So if you were to, let's say, bring this multiplication symbol over here, and let's say you had addition and subtraction, order of operation would say you have to do this part first. But if we were to put parentheses here,
Yeah, you'd have to do that.
then
part
we do this
first.
first. So let's think about that. If we group some things together, then we have to do that first. And that might help change how we use this. So let me go ahead and start from scratch. Consider using those parentheses.
And that's what I want you guys to do, because what we're going to do is we're going to take a break right now. You guys are going to work on that, incorporate some parentheses into that, see how that works, And we'll check that out right after this with a little bit learning about the ocean.
When I first started as a maritime archaeologist, you'd go out in a boat, you would take a look at a spot on the land and another spot, and if they lined up right, you'd figure that you were more or less over a shipwreck that you'd plotted. You'd jump into the water, swim down, and there it would be. And you might share that with the other diver that was with you, but these days, increasingly, we're using new technology, satellites that tell you exactly where you are on the surface, robots, highly sophisticated cameras, the internet, to broadcast what we do to a global audience so that you, the visitor, the person that's looking on, can participate in discovery, exploration, and most recently, even in the excavation of a shipwreck, in some cases thousands of feet deep. One of the things that we've learned when we look at shipwrecks in particular, but other parts of archaeology, is when something is preserved, when it's set aside, it's almost like money that you put in the bank. But it's money that you can't make another deposit to. Once you start taking it out, it's gone forever. That's why, as archaeologists, we're very careful to look and not touch more often than not. In the time I've been an archaeologist, I've seen the technology change so much that if I could go back and say, hold on, don't dig that ship up now. Let's wait 30 years or 40 years because we'll learn twice as much. I would go back and have that conversation with myself and others. But by the same token, too, what we also learn is that these shipwrecks not only are repositories of the past, they're people's graves in some cases. They're also wonderful marine habitats full of life. So why should I, as an archaeologist, go to the bottom and say, okay, we're going to take all of this marine life off, we're going to take away this home for all these fish, and we're going to bring it to the surface when it's there sitting as an untouched museum that meets all of those needs, or that's a beautiful place for divers to go and visit. That's why we have sanctuaries. That's why we set these areas aside. It's not to just go and take. It's to look, to observe, to appreciate, and in a few cases, if it's that important, to intervene, take maybe this or that. A doctor, when he operates, doesn't take everything out of you. He might take a little biopsy as a sample to learn what's making you sick. And so that's how we approach it with shipwrecks. That's how we approach it with most anything in a marine sanctuary. They are sanctuaries. They're conservation areas. They're sentinels that speak to how we are changing the oceans and how we're also working very hard to save the oceans and preserve what's in them. So we, for the most part, leave only bubbles and take only photographs.
All right, so Samantha, quickly read to me what you've got now.
4 plus 4 is 8 minus 4 divided by 4, which is 1, equals 7.
There you go. So 8 minus 1 is 7. So you were able to come up with it using parentheses. So did you learn a little something today?
Yeah.
You learned quite a bit today, didn't you? Okay.
Yeah.
Did you have fun today?
Yes.
Good. I'm glad you had fun and you learned something at the same time. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.